First, introduction, the problem of monolithic code. So far, most of the programs we've written consist of a single, continuous block of code inside the main function. This approach is called monolithic programming. Everything is in one big piece. While this works for small examples, imagine building a large-scale application. A game that needs to draw characters, calculate physics, and manage scores. A financial application that handles data validation, calculates interest, and generates reports. If we put all this logic into one giant main function, the code becomes hard to read, too much scrolling. Hard to debug. Where did the error occur? Impossible to reuse. You can't easily copy and paste 50 lines of complex logic. Second, the solution functions modular programming. The solution is modular programming, which is achieved through functions. A function is essentially a self-contained, named block of code that performs a specific, defined task. Think of it like building a car. You don't build the whole car at once. You build separate, reusable modules. The engine, the door, the wheel, the electrical system. Each module has a specific job. In C, we break our large problem into smaller, manageable, named functions. Every C program must have at least one function, main. Third, the three key benefits of functions. Functions are not just a good idea. They are essential for professional programming. They provide three major benefits. Reusability. Don't repeat yourself. D or Y. If you have a task that needs to be performed multiple times in different places in your program, e.g., calculating the area of a circle, you only write the code once, inside a function named calculateArea. Before, you copy the calculation formula 3 times. With functions, you just call calculateArea 3 times. This saves typing and prevents errors. B. Maintainability and debugging. If an error occurs, you know exactly which function is responsible. Instead of searching through 500 lines of code, you only need to check the 20 lines inside the function generate report. Functions isolate problems, making the code much easier to fix and update later. C. Clarity and readability. A function name instantly tells the reader what that block of code does. Instead of seeing 10 lines of confusing arithmetic, you see calculate tax income. The code explains itself. A well-structured main function essentially becomes a list of high-level steps. First, get user input. Second, process data. Third, display results. Fourth, anatomy of a simple function, the concept. Every function follows a standard conceptual flow. Input, arguments, parameters. The function takes necessary data to perform its job. E.g., a function that calculates a sum needs the 2 numbers as input. Process. The function executes the instructions inside its code block. Output, return value. The function often produces a result and sends it back to the part of the code that called it. E.g., the sum function sends the calculated total back. Fifth, conclusion and next steps. Functions are the architectural building blocks of structured C programming. They are crucial for creating code that is reusable, easy to maintain, and clear to read. In the next lesson, we will move from the conceptual understanding of functions to the practical syntax. Our next lesson is 5.02, Defining and Calling Functions. Syntax, Parameters, and Arguments.